Today we are doing implicit functions. Implicit functions. Implicit function is a function where x and y is not subject of the equation. Like if you observe the one we have been doing before, we have y equal to. Don't forget I think in my first video I said when I was defining function, I said y is a function of x. So y is depending on x. So but in this case, for those one we call them explicit function. But this implicit function, x and y they are not depending on each other. So which means x is not a subject, y is not a, so x and y they are depending on each other. But x and y, x is not in form of equation and y is not in form of equation. That is, x and y they are not subjects of the equation. They are both in the equation, but they are not subject of the equation. Though they are interdependent, but x is not the subject, y is not the subject. In that case, we call it implicit function. E.g., x raised to the power of 4 plus 2y cubed equals 7xy. If you look at this, they are just together. So y is not the subject, x is not the subject. They are just together. We call it implicit function. But note that there is a particular information, a very vital information in implicit. Note, for every differential of y, there exists dy dx, which means whenever you are differentiating y, for implicit, make sure you are putting dy dx. So now we can move on. These are the examples under implicit function. Find the derivative of the following implicit function. Question 1 says x squared plus 2y squared equal to 7. Derivative dy dx. Solution. So let's solve this solution. For question 1, we are given x squared plus 2y squared equal to 7. Now, for this kind of implicit function, you just differentiate based on the nature of the question. Now, this is ordinary x squared. I will differentiate direct. If I differentiate x squared, it will give me 2x. That is plus. If I differentiate y squared, it will give me 2y. 2y times 2, we have 4y. But don't forget, I said for every differential of y, there exists dy dx. It means whenever you are differentiating y, you have to put dy dx there. So because I differentiate y here, I will put dy over dx beside what I've done. You know, I've differentiated y, you put dy dx beside. Equal to, this is constant, 7. If I differentiate constants, the answer is 0. So this is dy dx, but my aim is I'm working toward dy dx. So which means I will make dy dx the subject of the formula. So these 2s will cross to the other side. It will now be 4y dy over dx equal to, if these 2s cross, become minus 2x. My aim is what? I'm looking for dy over dx, which means I will divide both sides, short form dbs. Divide both sides by the coefficient of dy dx, which is what? 4y. Which means my answer will now be what? 4y dy over what? Over dx over 4y equal to what? Minus 2x over what? Over 4y. This cancel this. So in conclusion, dy over dx. 2 can go, 2 can go. That is minus x. 2 in 4, 2. That is the final answer is minus x over 2y. That is my final answer for the dy over dx in question 1. For question 2, let's scrap it. It's very easy. So we are given this. We are given x squared plus y squared equal to x plus y plus 3. Now, if you want to solve this kind of question, it's similar to the first question we solved, the same pattern. I will differentiate x, I will differentiate y. So if I differentiate x squared, it gives 2x. Please follow up. Plus, now, if I differentiate y squared, it will give me 2y. But because I'm differentiating y, there must be dy dx. It will now be plus what? 2y dy over dx equal to, if I differentiate x here, it gives 1. If I differentiate y, it will give me 1. That is what? Plus what? 1 dy over dx. Because for every differential of y, there must be dy dx. This is constant. If I differentiate constant, it becomes 0. Don't forget, my aim is to find the y over dx. So from here, I will collect like same, there is dy over dx here, there is dy over dx here. Note, 1 dy dx is still dy dx. So 1 is just coefficient. So if this one cross, this one will go like this. It will now be what? 2y dy dx. If this cross, by crossing the sign of equality, it will become negative. Minus what? Dy over dx. Or if you like, you can say minus 1, same thing. Minus 1 dy over dx equal to, this one is not crossing, it's still there. If these 2x cross, become minus 2x. But dy dx is here, dy dx is here. I will need to factorize it out. So, which means, let me clean this side. Which means that my final answer from here, so dy dx is common here, I will factorize. So dy over what? Dx. Open it. So if I factorize dy dx out here, it will remain what? 2y. Then if dy dx in dy dx, that is 1. And if you look at it, there is 1 here already as a coefficient, minus 1. If I factorize, equal to 1 minus 2x. Without wasting time, divide both sides by what? 2y minus 1. So it will now be what? Dy over dx, bracket 2y minus 1 over 2y minus 1 equal to 1 minus 2x over what? 2y minus 1. This cancel this. So without wasting time, in conclusion, dy over dx will be equal to what? 1 minus what? 2x over what? 2y minus 1. That is the final answer for the second question under implicit function. Implicit. The last question, number 3. We are given that yx squared plus xy squared plus 8x equal what? 17. Now from here, if I want to solve this, the same pattern. But if you look at the nature, this one is yx squared, like product rule. So here we are using the principle of product rule, but it will now be partial derivative. Partial derivative. So from here, there is x and y. I will differentiate x and y here. Now, if I differentiate, I want to start from x. If I differentiate x here, it will give me 2x. Now, 2x, there is y before as a product. 2x, according to the principle of product, you differentiate one, you leave one, you multiply. So if I differentiate x squared, it will give me 2x. 2x times y, that's what? 2xy. I differentiate x, don't forget. But now, in this same question, if I differentiate y, it will give me 1. 1 times x squared, that is plus what? X squared. But don't forget, for every differential of y, there must be what? Dy dx. It will now be x squared dy over dx. I move to the next question, plus, if I differentiate x here, it gives 1. 1 times y squared. Don't forget, I differentiate x, it gives me 1. 1, because they are products. 1 times y squared, that's what? Y squared. In this same function, because they are products, I will also differentiate y. If I differentiate y here, which is y squared, it will give me 2y. 2y times x, that's what? 2xy. But because I differentiate y, there will be what? Dy over dx plus, if I differentiate x in 8x, it gives 1. 1 times 8, that is 8, equal to, if I differentiate 17, constant, becomes 0. So I will now group the family of dy dx. There is dy dx here, there is dy dx here. I group them together. So it will now be what? X squared dy over dx plus 2xy dy over what? Dx plus, this is what? But if you look at this, they are just ordinary variable without dy dx. You take them to the other side of the equation. So it will now be equal to what? If this cos become minus 2xy by causing the sign of equality. If this y square cost becomes minus y square, if this plus 8 cos become what? Minus 8. So if you look at the nature, there is dy dx common, I factorize. It will now be dy over what? Over dx, bracket. Now, if I remove the y dx from here, what will remain? S squared. S squared plus what? What of this one? 2xy. I factorize. Close it. Equal to what? Minus 2xy minus y squared minus 8. From here now, I'm working toward dy dx, which means I will divide both sides by the coefficients of dy dx, which is s squared plus 2y. S squared plus 2xy. So in conclusion, dy over dx will now be s squared plus 2xy. Sorry, s squared plus 2xy divided by x squared plus 2xy. I'm dividing both sides by the coefficient of dy dx, minus 2xy minus y squared minus 8 over what? S squared plus 2xy. So this cancel this. Without wasting our time, our final answer is here. Therefore, you can write it here. Our final answer will now be dy over what? Dx is equal to what? Minus 2xy minus what? Y squared minus what? Minus 8 over what? S squared plus 2xy. As simple as that. Thank you very much for watching.